In this lesson, we're going to talk about negating quantifiers. So when you negate a quantifier, pretty much the only thing to remember is that you switch the quantifier when you pass a negation through it. So we've talked about the existential quantifier, there exists, and the universal quantifier for all. And you switch from one to the other when you pass through a negation. So more precisely, if we look at statement 1 here, not for all x and s, p of x is equal to there exists an x and s such that not p of x. And for statement 2, to say not there exists an x and s such that p of x is the same as saying for all x and s, not p of x. So the negation is pulled past the quantifier to the statement p of x. And when you pull the negation past the quantifier, this there exists x and s such that becomes a for all x and s. And similarly in statement number 1, when you pass the quantifier through the for all, this for all x and s becomes there exists x and s, and the negation comes inside to the p of x. So let's look at a couple of examples to get an intuitive sense of why this is true. So if we let s be the set 0, 3, and 5, and p of x is the statement x is less than 4, then the following are both true because they're logically equivalent. So statement 1 would say it's not the case that all x and s, reading the math, we'd say not for all x and s, p of x, meaning not all elements of x are less than 4, right? Because 5 is in s, and 5 is not less than 4, so that makes this true. And you could also say there exists an x and s such that not p of x. In other words, there exists some element of x of s that is not less than 4. And right, that's also true because of 5. So 5 is the element that makes both statements not true. Similarly, we could look at an example of negating an existential quantifier. So let's let p of x be the statement x eats 100 pounds of pizza every day, and s is the set of all people. So we could say not there exists an x and s such that p of x. In other words, there does not exist a person who eats 100 pounds of pizza every day, which I believe to be true. Whether it's true or false, I guess statements 1 and 2 are still either both true or both false. The point is that statements 1 and 2 are logically equivalent. If it is true, it's not going to be true for long. So a logically equivalent statement to that, to saying that there does not exist any person who eats 100 pounds every day, is to say that every person does not eat 100 pounds of pizza every day. So in other words, for all x and s, not p of x. So just to recap, once again, if we bring this negation through the quantifier changes from there exists to for all, and then this negation goes inside to here.